Start.
Hello everybody. Today I am going to teach a topic on fatty acid oxidation. So before going to topic, first we have to know what is oxidation. Oxidation meaning the breakdown process. In fatty acid oxidation, the fatty acid is breakdown to form acetyl-CoA, which is a form of ATP. In fatty acid oxidation, the process is called beta oxidation. Why it is called beta oxidation? Because in fatty acid breakdown or fatty acid oxidation, the cleavage or the breakdown processes occur at the beta carbonatom. So, what is called beta carbonatom? Which the beta carbonatom is that carbon which is the second carbon attached to the carboxylic group, means COOH is the carboxylic group. So the second carbon attached to the carboxylic group is the beta carbon atom. For the beta oxidation process, there are three steps. The first step is activation of fatty acid, which is occur in the cytosol. The second step is transport of fatty acid into mitochondria. Means the activated fatty acid is transferred to the mitochondria. And the third step is the proper beta oxidation cycle, which is occur in the mitochondria. So comes to the first step in cytosol. First the fatty acid is activate. So here we take an example of palmitic acid, which have 16 carbon atom, that is C16. So in this process, the palmitic acid is activated to form acyl-CoA, or this is called palmityl-CoA. And for this process or for this activation, 2 ATP is used. And the enzyme which is responsible for the activation is called thiokinase. So now we have found the palmityl-CoA or activated acyl-CoA. Now the acyl-CoA is second step is transmit to the mitochondria. But acyl-CoA individually not transmit to the mitochondria, because of which the acyl-CoA take a help of carnitine to comes under to the mitochondria. So the acyl-CoA is now attached to the carnitine and form acyl-carnitine, and the acyl-carnitine is transmit to the mitochondria, and here the acyl-CoA is clipped from the carnitine, and carnitine again return to the cytosol. Now we have found the acyl-CoA. Now in mitochondria, the acyl-CoA is go under to the beta oxidation process. This is the proper oxidation process or the third step of beta oxidation or the proper beta oxidation. So it is the step of beta oxidation. In beta oxidation, there is 4 reaction. One is your oxidation, or it is called dehydrogenation. Second step is the hydration. Third step is the again oxidation or dehydrogenation. And the fourth step is the thiolysis or cleavage. Okay. So in first step, acyl-CoA is oxidized or dehydrogenated. It means a water molecule is removed from acyl-CoA. So in acyl-CoA, in this step, a water molecule is removed and it forms alpha beta unsaturated acyl-CoA. And in this step, one FAD is come. The FAD is the hydrogen acceptor and it become FADH2. And FADH2 have 2 ATP molecule. Okay. Then now comes to the second step. In second step, the alpha beta unsaturated acyl-CoA is hydrated. Means again a water molecule is attached to the alpha beta unsaturated acyl-CoA. And here the enzyme is acyl-CoA hydratase. Here you saw the water molecule is attached to the alpha beta unsaturated acyl-CoA and it become beta hydroxy acyl-CoA. So it is the second step. Then come to the third step. In third step, again oxidation occur, means again a water molecule is removed. So from beta hydroxy acyl-CoA, again one atom molecule is removed and it become beta ketoacyl-CoA, and the enzyme responsible for this reaction is beta hydroxyl acyl-CoA dehydrogenase. And where the water molecule is removed, here the hydrogen acceptor is NADH. So one NADH have 3 ATP molecules. Now comes to the last step, or thiolysis or cleavage or breakdown. So in last step, the beta ketoacyl-CoA is cleaved or breakdown or thiolysis to form acyl-CoA and acetyl-CoA. So it is the final method, acetyl-CoA, and this acyl-CoA again go to the beta oxidation cycle. This beta oxidation cycle is continue up to the C16 becomes C2. Okay. So what is the energetic calculation for beta oxidation? So you know 1 NADH is equal to 3 ATP. 1 FADH is equal to 2 ATP. And here the acetyl-CoA. 1 acetyl-CoA is equal to 12 number of ATP. Okay. So for a palmitic acid or for a even carbonatum fatty acid, the beta oxidation cycle is N/2 minus 1. And for acetyl-CoA, it's N/2, means 16/2 is equal to 8. Means during a oxidation of palmitic acid, the acetyl-CoA is equal to 8 number of acetyl-CoA are removed. And the beta oxidation cycle is 8 minus 1, 7 cycle. So here in one cycle, 1 NADH is removed. So in 7 cycle, 7 into 3, 21 ATP is removed. In one cycle, 1 FADH is removed. So in 7 cycle, 7 into 2, 14 ATP is removed. In total palmitic acid oxidation, there is 8 acetyl-CoA. So total ATP is equal to 8 into 12, 96 ATP. So total ATP is total 31 ATP. But remember the previous, in activation process already 2 ATPs are used. So we have to minus 2 ATP. So is equal to 129 ATP. So in a beta oxidation process of palmitic acid, total ATP are 129 ATP. So it is the energy calculation for a beta oxidation. Thank you.